This is the presentation on Gay-Lussacs Law. Going to be looking at a couple of different things here in this lecture. The main thing is the law with pressure and temperature and how they are going to relate to each other. First thing we're going to want to look at is the definition. That is, the pressure of a gas is directly proportional to the Kelvin temperature if the value or if the volume remains constant. Again, can't stress this enough. Covered it before a couple of times. Temperature needs to be in Kelvin. Very important to have that. Again, the volume remains the same. The number of gas particles remain the same. So we're just dealing with pressure and temperature. So our equation is going to be pressure times pressure 1 times temperature 2 is going to equal pressure 2 times temperature 1. Since they are directly proportional means one goes up, the other goes up. One goes down, the other goes down. There's a nice video on my PowerPoint. You should go to my PowerPoint slides and run through them. They're going to be just like the ones you see here. But there's a video on the next slide that shows this temperature and pressure very, very well. There's also an applet. If you look down on the last thing on this slide, see the word applet. You go to a or go to the internet for an applet there that also describes this law in a little more detail. So that's where the video would be found. So let's do a sample problem. Here's a question. What pressure will a sample of nitrogen have at 25 degrees C if the gas has a pressure of 557 torr at a temperature of 8 degrees C? The volume remains constant. So as always, with all these problems, we want to write down our knowns and unknowns. We have to make sure we're matched up appropriately. P1 and T1 are matched up. P2 and T2 are matched up. So it says, what will the pressure be? So P1 is question mark. Of a sample of nitrogen have at 25 degrees C. So that's going to be T1. We know that P1 and T1 match up. It asks what the pressure is at that temperature. So those will go together. If the gas has a pressure of 557 torr at 8 degrees C. So that's the first thing we want to do, is match up those knowns and unknowns, our pressures and temperatures. The whole key here, again, is Kelvin. Plus 273 will give us our Kelvin temperature. That's going to be 298. And if we add 273 here, it would be 281 K. So again, change everything to Kelvin. Then we have our formula. P1, T2 is equal to P2, T1. Now we have our formula. We have our knowns and unknowns. We can just plug the numbers in. Let's take a look. P1, sitting right here is question mark, so we just write P1 times our T2, 281K, equals, now we have our pressure 2, 557 torr, times our T1, that's going to be our 298K. If we need to solve for P1, we need to get it on its side by itself. So we just subtract or divide 281K from both sides. That'll eliminate that whole side. Our Kelvin temperatures will cancel. So what we will end up having is our 557 times 298 divided by 281, and we'll come up with our answer of 591 torr as our final answer. Again, the whole key, writing in your knowns and unknowns, writing down your formula every single time. This is our third gas law now. Going to be doing the combined gas law next, and then the ideal gas law. So we're going to have 5 gas laws. If you don't write down your knowns and unknowns, you're not going to know which law to use, and so you're going to get confused and probably do the wrong thing. So writing down your knowns and unknowns, writing down the formula just makes it really, really easy. Now that we've had 3 gas laws, one of the toughest things for students is to do is recognize which gas law to use. Again, that's why we write down our knowns and unknowns. Makes it a little bit easier that way. So we have some questions here that asks us, which gas law will we use? We're not going to solve these problems. We're just going to decide which gas law that we're going to use. So given 90 milliliters of hydrogen collected when the temperature is 27 degrees C, how many milliliters will the hydrogen occupy at 42 degrees C? So we need to decide what gas law to use. Again, if we write down our knowns and unknowns, it's going to be very easy. It says the first few words, given 90.0 milliliters, that's going to be our volume. So it's going to be our volume. It's collected at a temperature, T1 equals. We also have a T2 here at a second temperature. It says how many milliliters. Volume 2 is equal to question mark. So now we have a formula with the unknowns and knowns and unknowns. We need to choose the formula with volume and temperature. Well, that would be Charles's law, dealing with volumes and temperatures. And there's our equation. We just plug the numbers in. Let's do another one. A gas has a volume of 125 milliliters. Volume equals. When the pressure, P1 equals. We can stop there if we want because we already know what law it is. The law that involves pressure and volume is going to be Boyle's law. It deals with pressures and volumes. How many milliliters? V2 equals question mark. Standard pressure, P2 would be standard pressure. Now the question is, what is standard pressure? If you look on the front page of your packets, you will see what we had on our variables. You'll see that pressure has a number of different standards to it, depending on what units you're using. So standard conditions, if you're talking atmospheres, is 1. If you're talking bars, it's 1.013 and so forth. In this equation, we're looking at kilopascals. So for kilopascals, we are talking 101.3 kilopascals is standard pressure. So 101.3 kPa is the pressure that we would use for standard pressure, because we have to use the same units all the way across the board. So that's what we would use. We'd use kilopascals. And our last problem here, again, which gas law would you use? Temperature of a sample in a sealed container at 30.0 kilopascals, so that's going to be pressure, is increased from minus 10 Celsius to 100 degrees Celsius. What will the final pressure be? This one is looking at pressure and temperature. So the gas law that deals with pressure and temperature would be Gay-Lussacs Law. Again, writing down your knowns and unknowns will really help you out choosing which law to use so you can plug the numbers in appropriately. Again, you want to know which law it is because sometimes P1 For example, Boyle's Law, P1 and V1, they're both on the same side. V2 and T2, or V1 and T2. You have to know where to put your volumes, where to put your temperatures. So they're gonna change. They're gonna vary a little bit. So make sure to know which law you're using and which order they go in. That concludes our presentation.